A few months back, Unexpected Maker made a video about the pick and place turntable that he uses to populate his prototype PCBs. After watching the video, I remember thinking, what an awesome idea, and then thinking I could really do something with this concept, seeing as I currently assemble all my boards manually. And so it was that the pick and place wheel was born. Before I proceed with the video, I'd like to give a huge shout out to Sean from Unexpected Maker for inspiring the pick and place wheel. I'll link to his channel in the video description. If you're into electronics project, you will really love his channel. This video is sponsored by JLC PCB. More on them at the end of the video. If you assemble some or all your PCBs by hand, this setup will look familiar to you. To populate a PCB, I would normally have all the components on the table like this, along with the pre-pasted PCB and a spreadsheet for the board I want to populate. This spreadsheet will usually contain information like component value, footprint, designator, and any other information that would enable me to accurately place the components. I would often also have my laptop close by so I can confirm the position on the board where specific components should be placed. With this process, I usually avoid any placement errors, but this is not exactly an efficient process, especially if you're working with multiple PCBs. So my goal for the pick and place wheel project is to make all the processes associated with manual PCB assembly as seamless and efficient as possible. There are 3 parts to this project. The first part is the wheel itself. Its main purpose is to hold the components in index positions during the assembly process. It also serves as the placing surface, and it's also used as storage for the components. The second part is the electronics that gives the wheel its position indexing capabilities. The final part is the desktop application, which ties it all together. The wheel primarily serves to hold your components in index slots for when you're populating a PCB, but it can also be used as the permanent storage for those components, thanks to the built-in locking mechanism. If you take a look at the transparent top cover, you'll notice the little flexible tabs glued to it. These tabs fit into appropriately sized locking slots on the pick and place wheel. The slots are at a slight angle so that when you turn the top cover in one direction, it creates a 1mm separation from the wheel, allowing it to rotate freely during board population. And when the wheel needs to be stored away, the cover can be turned in the other direction, which lowers it down onto the wheel, sealing the components in their slots and preventing them from falling out or falling into another component slot. This locking mechanism works really well for components as small as 08, 05 resistors or capacitors. But for smaller components like 04, 02 resistors and caps, the seal provided by the top cover is usually not enough. So I've also designed this 3D printed CPU seal. This together with the top cover provides a very good seal for all types of components, even the super tiny ones. So instead of having components in the anti-static bags that they came in, the pick and place wheel can be used to index and store them. The pick and place wheel is also designed to be modular, which means it can be assembled to suit specific PCB projects. Each of the slots can hold about 2000 0402 components, or 600 0603 components, or 300 0805 components, or 120 1206 components. And you get 48 slots in wheel 1 and 24 slots in wheel 2. For placing bigger parts like USB ports, LEDs, power inductors, or connectors, there are bigger slot versions of the wheels. These wheels are similar to their counterparts, except that they have bigger slots and as a result a lower slot count. So this has 8 slots while this has 24. This has 16 slots while this has 48. The pick and place wheel supports all possible combinations of these wheels, so you can match them however you like. This is the placing surface. It's where you place the board that you want to populate. It goes on top of the wheel like this, and just like the wheels, there is also a bigger version to hold bigger PCBs or to populate multiple boards at the same time. Its size, however, won't allow access to the inner wheel, so only the outer wheel can be used with the large placing surface. I have mentioned indexing a couple of times in this video, but I haven't explained how the wheel achieves this component indexing, which is the main function of the wheel and the reason I designed it in the first place. Each slot on the wheel has an index. This index is used to identify and place the components that are stored in them. This is possible because the wheel itself is one giant rotary encoder, or more accurately, contains 2 rotary encoding wheels. The pick and place wheel uses my signature magnetic rotary encoding method, the same rotary encoding that's featured in the Hamsville dial project. So if you take a look at the bottom of the wheels, you'll notice a similar magnet setup. The magnets encode the slots on the wheels, so the number of magnets on each wheel is proportional to the number of slots on the wheels. The accompanying board has all effect sensors on it, which are used to read and interpret the analog values from the magnets as the wheel rotates. The resulting encoding data is how the slots get their indexes. If you've seen my previous videos, this will look familiar to you. If not, I recommend you watch the magnetic rotary encoding video I made a few months back to better understand this rotary encoding method. The board is your typical microcontroller board. It features 4 all effect sensors for reading the analog values from the wheels, 2 analog comparators for ensuring accurate encoding of the wheel's rotations, and 2 addressable LEDs that shows you the status of the wheels. The board is controlled by the SAMD21G chip, which is the same as the Arduino Zero boards. To keep with the modular theme of the pick and place wheel, the board is also easily detachable, which means you can make as many wheels as you like, and you would really only need one board, since you can easily swap the boards from one wheel to the other. The same board will also support any configuration you choose for the wheels. Desktop application is the most important part of this project. The pick and place wheel is all about simplifying the manual pick and place process, and the software is integral to achieving this goal. Whenever you're populating a PCB, there are 2 main things you need to know: the specifications of the component that you're about to place, like its value and its footprint. The second thing you need to know is the location on the PCB where the component should be placed. This is where the software comes in. It uses the actual pick and place data generated for your specific PCB together with the image of the board to create pointers that tell you where and how to place parts on the board. This, in conjunction with the position information from the wheel, is what constitutes the complete manual pick and place solution. For every PCB that you design, you usually have the option to generate a pick and place file. This file will contain information like component name, value, and footprint, but most importantly, it will contain the X and Y position for all the components on the board. The second thing you can easily generate from your PCB design is a 2D image of the board. Most PCB design softwares will allow you to preview your PCB in 3D. From this 3D view, you can easily generate an image that accurately represents the board. The image doesn't have to be the same size as the board. It just needs to be in the same aspect ratio as the actual board. So when you load the pick and place CSV file and the board image into the app, it reads all the data from the CSV and it also displays the image of the board. So if I check under the components dropdown, I can see a list of all the components used on this board. And if I select any of them, the app uses the coordinates from the CSV file to generate pointers on the image to show the location of that component on the board. Whenever you load a new CSV into the app, a new column is created inside that CSV file. This column is titled Pick and Place Wheel Position. This is where the slot indexes for the components are stored. The position information on this column is also what links the physical pick and place wheel to the app. So you'll notice that some of the rows say unloaded, indicating that those components don't have an index in the pick and place wheel. The components that have been loaded into the wheel will have their index shown under the column. So this row, for example, tells me I have 10 kilo-ohm 0603 resistors in slot 19 of wheel 1. And this row tells me I have 30 ohms 0603 inductors in slot 20 of wheel 2. All the information used and displayed by the app comes from this one CSV file. The app only makes it easy to visualize all the data in relation to the specific board. So during the actual pick and place process, the pick and place wheel connects to the app through the serial port and sends the slot indexes to the app as a string through serial communication. The app then uses that index to pull all the information about the component from the CSV file and then shows you everything you need in order to confidently populate the PCB. Before you can use the pick and place wheel to populate a PCB, you need to go through a first-time setup process. This process involves assembling the wheel to suit the PCB project, generating the required files, and then loading and registering the components into the wheel slots. This is a one-time setup process, and it's only required whenever you assemble a new pick and place wheel. Just like I'm going to be showing you in this video, I already have my main wheel, which I have set up with all my frequently used components. So for this video, I'll simply be setting up the wheel for its own board. To assemble the pick and place wheel, you'll need the following parts. The wheel base, which is 3D printed. Wheel 1 and wheel 2, also 3D printed. The placing surface, 3D printed as well. The transparent wheel covers for wheel 1 and 2. These parts were designed to be 3D printed or laser cut from a 2.4mm thick transparent acrylic. I'll include the DXF files with all the other downloadable files. You'll also need 5 locking tabs for wheel 1 and 3 locking tabs for wheel 2. This part and 3 different sizes of ball bearings, some 8mm magnets, 3 M2 by 8 self-tapping screws, 8 silicone rubber base pads, an optional 1mm thick silicone mat for the placing surface, a 3D printed funnel for loading the components into the wheel, and finally the optional 3D printed TPU seal. The actual assembly is really straightforward. You have to first install the magnets on the wheel. The magnets should be installed with an alternating pole configuration, just like this. It's also a good idea to secure the magnets with some glue. The next step is to glue on the locking tabs for the transparent top cover. Once that's done, the wheel can then be put together by first installing the 16004 bearing followed by the bigger wheel, and then the 6810 bearing followed by the smaller wheel. The holder for the last bearing can then be attached and secured using 3 self-tapping screws. The wheel covers can then be attached and you should hear the covers snap into position. The 16001 bearing goes on top like this, and that's followed by the placing surface. The final steps will be to install the main board to the wheel. And then to attach the silicone rubber-based pads. The next step after assembling the wheel is to generate the required files for the actual pick and place process. Depending on the PCB design software you use, this process might look a little different for you, but the general idea is still the same. The first file I need is the pick and place CSV for my board. I use Altium to design my PCBs, so generating the file is really easy. But I must first make sure that the board origin is set to the bottom left corner, and as you can see, I have already done this for my board. So I'll just need to click on File, Assembly Output, and then Generate Pick and Place File. A setup dialog should appear where you can select all the data you want to be included in the file. The generated file should include the component's name, footprints, designators, values, layers, and the most important, the X and Y position data. You can include additional data if you like, but the ones I mentioned are the essentials. You should also make sure that the file uses dot separation for its values and not comma separation. Once I click on OK, Altium generates the pick and place file, which can be found inside my projects folder. I can preview the file in Excel to confirm that the data is in proper order. You should also take note of the board size, that is, the width and the height of the board. This will be required later. The second file I need to generate is the board image. So if I switch to 3D view, I get a pretty accurate representation of my board. I can simply grab the image from the screen as it is right now, and that will work just as well. But I like to first export the 3D view as a PDF, which is another useful feature in Altium Designer. Opening the 3D view in the PDF reader allows me to slightly modify the look of the PCB. So I simply select the top view and then choose an appropriate lighting. Once I'm satisfied with how the board looks, I can grab the image using the snipping tool. The image also needs to be cropped to the edges of the board. This will ensure that the image and the actual PCB share the same aspect ratio. The final step will be to copy both the pick and place CSV and the board image into a specific folder. Under Documents, there should be a folder named Pick and Place Wheel. This is where I store all my pick and place wheel projects. Inside, you'll find a folder for my main pick and place wheel, and you can see I named it my purple wheel. You can of course name it whatever you like. Inside that folder, you can see all the PCB projects associated with that wheel. But since I'm setting up a new wheel, I'll have to create a new folder for it, and I'll name it my green wheel. Inside this folder, I'm going to create another folder to hold the generated CSV and the board image. Once both files are in the appropriate folder, I can proceed to setting up the application for the pick and place project. Once the app opens up, I can click on Load to load the files I've just prepared by simply locating and selecting any of them. Once the app reads the files, the board image should be displayed and the loaded files should be listed on the top right corner of the app. I can name the project by double-clicking on New Board. The next step is to point the app to all the required data from the CSV file by simply matching the selections to the appropriate column from the pick and place file. So components will be matched to the column that holds the name of the components. For me, that's the comments column. Value will be matched to the column that contains the values of the components. Footprint will be matched to footprint, and so on. I'll also enter the width and height of the board. And also select the appropriate slot count for my wheel. The wheel has 48 slots for wheel 1 and 24 slots for wheel 2, so I'll set it accordingly in the app. The last selection, wheel position, has to be matched to the column that will hold the indexes, which is the pick and place wheel position column. After completing the selection, I can save it into a configuration text file. Doing this will make sure that the application remembers all the selections for the next time I load the files. So if I restart the app and reload the pick and place files, the app will automatically update the selections. At this point, I am now ready to start loading components into the wheel. But first, I have to connect the wheel to the app. Once the app successfully connects to the wheel, you will immediately notice the wheel's status box on the app blinking. This indicates that the wheel has not been reset to its default start position. This is equivalent to a 3D printer that needs to be homed before starting a print. To reset the wheel, I simply have to rotate each individual wheel to the slot with an arrow head and then click on the reset button. After the reset process, the index shown on the app should now perfectly match the wheel's rotation. The wheel is now ready to be loaded, and so under Components, you can see a list of all the components used by this board. If I select any of them, the app will generate pointers to tell me where the components are located on the board. To load a component, I first have to pick it out of the pile, and then select the component from the components list. In this case, I am holding 604 ohms 0603 resistors, so I select the same from the components list. Next, I need to find a free slot on the wheel. Since this is a new wheel, I'll just select any arbitrary slot. I can then unload the resistors into the slot using the 3D printed funnel. After loading them into the wheel, the final step will be to click on the Update Components Position button. With that, I have now successfully loaded and registered the 604 ohms 0603 resistors into slot 22 of wheel 1. Now, I just need to repeat the process for all the other components required by the board. Whenever a new component is loaded and registered, its color under the components list will change from orange to green. You will also notice that when I rotate the wheel to the slots where I've loaded some components into, the information about that component is displayed in the status box, and the generated pointers also matches the same components. Assuming all the required components have been loaded into the wheel, the only thing that's left to do is to put the actual board on the wheel to begin the assembly process. Part of the beauty of the pick and place wheel is that you only need to set it up once, and then you can place as many boards as you like. This was just a quick demonstration of the wheel's operation. If you would like to see my full process using the pick and place wheel, you can watch the PCB assembly video that should follow this one. I honestly cannot overstate how convenient the pick and place wheel system has been. It has made organizing my components really easy, and my PCB assembly process hassle-free and actually enjoyable, a process that used to be quite tedious. If you would like to make one for yourself, I'll link to all the 3D printable files in the description, as well as the detailed documentations on everything you need to know about the pick and place wheel. I'll also have the board available for purchase on my Tinday store. If you've made it this far into the video, first I want to say thank you for watching. And secondly, you're obviously into PCB projects like this, so why not try out GLC PCB for your first or maybe your next PCB project? They produce really high quality PCBs for really cheap prices, and I personally use them for all my PCB needs. You can use the link GLCPCB DYE to get an $18 coupon towards your first order. Thank you guys for watching, and until the next video, bye.